Hey there, Mr. Witherow here. All right, we're going to start multiplying polynomials. All right, so the two polys that we're going to talk about today are monomials and polynomials. So we're going to multiply that. So basically, we're going to take a one-term thing and multiply by a many-term thing. That's what mono means one, poly means many. All right. Now we have to remember that the product rule of exponents. We have to remember that, which means that we're just going to multiply the coefficients, which I call the big numbers, and we're going to add the exponents, which is the little numbers. All right. So that's the key. That's one of the rules of exponents that we use all the time. Is the product rule. Multiply coefficients, add the exponents. Now, believe it or not, you've seen this. You've seen it when we talked about distribution or distributing. All right. So you've done this before. We used to do this all the time when we just only had one variable with no exponents. When we took the 3 and we multiplied by the x and we got 3x, and we took the 3 and we multiplied by the 4 and we said 12. So you've done this before. What we do now, especially in algebra, is that we start putting more variables with more exponents. That's it. So that's what this comes into play. So we have to just remember we're going to multiply the coefficients, add the exponents. So let's take a look at this. So we have this, k times k minus 9. So same thing up here. You got the one term that's sitting out here, and then you're going to have the 2 or 3 or 4 terms that are on the inside here. I don't care how many are on the inside. We're still going to take the k and we're going to multiply it by the k, and then we're going to take the k and multiply it by the negative 9. So k times k is k squared. And minus k times 9 is 9k. That would be my answer. Because again, the exponents are 1 and a 1. 1 plus 1 is 2. And then when we say k times 9, remember that we always write the coefficient first. We don't write it k9. That's a dog. Ha. So k squared minus 9k. All right? So not anything too crazy. Then we start getting into a little bit more of a challenging problems. And those look like this, if it will focus. Give it a second. There she is. Okay? So again, same thing. We have one term out here, which is a monomial. We have two terms in here, which is called a binomial, right? We can always just classify them as polys, right? So we take this and we're going to multiply by here. And we take this again and multiply by here. So with the product rule, we say 3 times negative 2, which is negative 6. The variable is c, so the base is the same, so we can write that down. So then 5 plus the 1 is 6. Remember, we add the exponents. And then this is a minus, so we're going to write down minus. And then 3 times 5 is 15. Well, don't forget this c to the 5th. There's no c here, so we're going to write down c to the 5th. Because remember that this whole thing is being multiplied by this thing over here, which just means that it's the coefficients. So this is my answer. So negative 6c to the 6th minus 15c to the 5th. We don't try to combine it. We don't do anything with it. That's it. Two terms here, probably going to put us two terms in the answer. All right? All right, so how about this one? Now we're starting and getting in some fun stuff here. Okay, so we got a negative 7 out here. So that just remember that when we multiply negative times a positive, it's going to be a negative. And then when we multiply negative times a negative, it's going to be a positive. So we're going to multiply this and we're going to multiply this. Remember, if you don't see an exponent, it is 1. Just remember those. All right, so negative 7 times 9 is a negative 63. And then we put our c down, and then we add the exponents. 3 plus 2, right? 3 plus the 2 is 5. Put our d down. 2 plus 2 is 4. Don't put this minus down yet, because remember, it's a negative 7 times a negative 4, which would be positive 28. 3 plus the 1 here is 4, so c to the 4th. And 2 plus the 5 is 7. So then there's our answer. All right, so multiply the big numbers, add the little numbers all day long. All right, so let's put distributing with adding and subtracting and getting simplification or simplifying. All right, what that means is that we got a couple steps here. We got to get rid of the parentheses, right? To get rid of the parentheses, we're going to have to distribute. Then we're going to gather like terms or combine like terms. And then we always have to write it in standard form. All right? So we're going to distribute, combine, and then write in standard form. So what that looks like is something that looks like this. There we go. All right. So we have the monomial times a binomial plus this monomial, okay? So we're going to take this -2 and we're going to multiply it by just the ones inside the parentheses. This plus 7, I'm going to just drop down. It has nothing to do with this multiplication over here. It's outside the parentheses. So don't take this and bring it all the way over here that I see some kids do. Don't do that. This plus 7 is just hanging out until you get rid of this parentheses. So -2 times +3 is a -6. X times x is x squared. -2 times -4 is a +8. And then don't forget your x. So now, notice we got rid of the parentheses. So now we get to gather like terms. We get to the combine like terms. Standard form tells me that I have to write it in the highest exponent first. So who has the highest exponent? It looks like this guy is. And then these two are the same, so I get to combine those. So we drop this -6x squared down, and then we say 8 plus 7 is 15x. Do not do anything with the exponents. This is just gathering like terms. I have 8 x's, and then I add 7 more to them. So I have a total of 15 x's. So this would be my answer. So notice that this right here drops all the way down here. This is what the answer is. Here's your work in between. All right. How do they make them tougher? Well, they just add more stuff to it. That's it, folks. All right. For this type of stuff, they're just going to simply ask you to keep doing it over and over and over again. So here we go. We're going to take this 4x squared and we're going to multiply it by everything on the inside here. There's 3 terms on the inside. So I'm going to multiply this 3 times to get rid of this parentheses. So 4 times 2 is 8. 2 plus 2 is 4. 4 times 1 is 4. 2 plus 1 is 3. 4 times -5 is a -20. And then it just comes with the x squared. That's what we do. Notice that it's already looking like it's in standard form. 4, 3, 2. Pretty cool. All right, to get rid of this parentheses, we have to distribute this -x. Folks, I'm going to tell you, the best thing to do is to always just cover it up. If I got rid of that, cover it up. Now you see that it's -x, right? So now I'm going to distribute this -x to everybody over here, which just means it's really a -1, remember? Remember, we just don't write it. So -1 times +1 is a -1, and then we have x1 plus 3 is 4. Negative times a positive is a negative, and we put the 5 down. 1 plus 2 is 3. And then -x minus, times a -3 is a positive 3x. And then we bring down our plus 17. All right, because this 17 has been hanging out here until we got rid of all these parentheses. It's just sitting there waiting, chilling. All right, now we got to look through here. Again, we have standard form means that we look at the highest exponent. It looks like it's 4, right? So we have 8x to the 4th minus 1x to the 4th. So 8 minus 1 is 7, x to the 4th. Remember, we do not do anything with the exponents. We're just gathering them up. We have 8x to the 4th, but we spent 1, so we're left with 7x to the 4th. Then we have x to the 3rd. We have 4x to the 3rd, but we needed 5x to the 3rd, so we had to borrow an x to the 3rd. So we say minus x to the 3rd. We owed somebody we owed somebody 20x squareds, right? Well, there is no other x squareds. So I guess that means we just write it down. And then we have x's over here. And there's no other terms that has just x, so we just write it down. And then our last term, our 5th term here, we didn't have any other constants, so we write it down. So sometimes we just simply just write it down because there's nothing to gather. You only gather the like terms. So we only had to gather the x to the 4ths and the x to the 3rds. Everything else just fell straight down. All right? Multiplication, we start with the distributive property first. Remember, when we multiply the big numbers, we add the little numbers. When we add or subtract terms, we don't do anything with the exponents. All right, keep having fun with math.